Hello everyone, welcome back. So in our last tutorial, we have seen how to use the pre-built MNIST datasets to train a simple neural network. And in this tutorial, we're going to see how to pre-process images to build our customized dataset. And we're going to get the images from the Microsoft dataset, and then we're going to add the labeling to the datasets, and we're going to resize and grayscale the images, and we're going to add the labels, and then we're going to store the dataset as an NumPy array. Let's go and check it out how to do it. So for that, I'm going to import some modules. Basic one is OS. Since we need to read the files from our file system. Then the next one is CV2, which is OpenCV. If you don't have, just go to your terminal and then type a pip install or Python OpenCV. It will install the CV2 module for you. And then the next one is import NumPy SMP, and then the last one is import GQDM. GQDM comes default with Pytorch. This module is used to show the progress bar when we are doing some processing. And I'm gonna add a flag called rebuild dataset as true, since we haven't built the dataset yet. And actually we could add this later. So first I'm gonna add a class cat with cat and dogs. And I'm gonna declare the image size as 50. Before that, what we have to do, we're gonna download the dataset. What we are going to do here is we're going to get the cats and dogs images, and then we're going to label them, and we're going to resize them using the OpenCV. So for that, we're going to download the images from the Microsoft dataset. For that, you can just go to Google and say cats with dog Microsoft dataset. It will take you to that link, and just click download. It will download the dataset zip file, which I've already downloaded. So once you download it, you can open the Explorer and see you will have the pet images folder. Inside you will have the cat and dogs folder. Here you will have the numerous cat images. So, but the images are in different size, so you will not be able to see, you will not be able to feed the images directly into the neural network. We need to do the pre-processing with these images. And the images are in color. We don't need the color images to do the classification. So we're gonna make it grayscale. And let's see how to do that. So once you downloaded the dataset zip file, and then you just need to extract it, then copy the pet images folder into your Jupyter Lab environment. Then we're going to resize resize all the images into 50 by 50. So we're going to keep the image size as 50, and then we're going to say the cats folder as, I mean, like cats folder path images slash cat. We're going to say the docs folder path dog, and we're going to add the labels. So here we are going to make an object like if it is cats, and it's gonna be labeled as 0. If it's dogs, and it's gonna be labeled as 1. So even if you have another animal, it should be labeled as 2, 3, 4, 5, like that. So that's the way it has to be labeled. We can't feed the string into the neural network, so we have to label each of the category into a number. Need to assign it to a number, and then that number will be assigned to the the number will be used as a output label of the neural network. So here the cat is assigned as 0 and dog is assigned as 1. Then we are going to have the train data array initialized empty, and then we're going to have a check of cat count and a dog count, since we are just training one neural network to identify both the two different types of categories like dogs and cats. We need to keep the count, as same as, we have to keep the count of the cats as similar as dogs. Otherwise, the network will be imbalanced. So we need to keep looking the balance properly. Otherwise, we will have the very imbalanced neural network. So we're going to count the number of dogs images and the number of cat images in the dataset. So we've declared all the basic variables. Now we're going to add a function to create the dataset. I'm going to say the make train data set. Then I'm going to add a for loop, and we're going to take the cat images and then the dog images. For that, I'm going to use the label. So first it will be iterating through cats, and then it will be iterating through dog folders. I'm going to print the iteration title, and then I'm going to add the another loop here, file, and I'm going to add the TQDM to show the progress bar, and then os.list directory. And I'm going to take the cat label first, cats directory, and I'm going to make the full path here, os.path.join the label, file. So here we are just joining the directory with the cat directory with the file name. So here it will fetch the file name, it will then iterate through, it will go to the cat directory and iterate through each file. Then the file name, we are joining the file name with the directory, and then then the whole path, it will be assigned to the path variable, then the entire path of the image file is assigned here, and then we are gonna load that image using the OpenCV cv2.imread. Path comma cv2, and we are going to open it. While reading the image itself, we are going to convert it as a grayscale. Image read dot, sorry, grayscale. Sorry, it might be in caps. Grayscale. So we just loading the image file into memory in the grayscale format. And then we are also going to resize this image to 50 by 50. cv2.resize image comma resize size, which is self dot image size comma image size, which is 50 by 50. So we are passing the 50 by 50 size which we declared here. So this will resize the image. And then we are going to add this image to our train data array. Sorry, we're going to append it. Since we have already initialized the train data to empty array, we are going to append it, but we are not going to append it directly. We are going to append it as image and the label. So we are going to convert this image as a numpy array and p.array. And then we are going to assign the respective label as np.I of 2 of self dot labels of label. So what we are doing here, we are just creating the classification vector array, and so actually what we are doing here is, let me show you. So if you just create a numpy array of 3, so it will create the 3 by 3 cross matrix as a identity matrix. So if you create a 2 np I of 2, and it will create the identity matrix like this. So what we're going to do here is like 1. Oh, sorry, it's going to be 2. Of 0. So if we're going to have the npi2 of 0, then it will give you the 1, 0, which means cat is 1. We are assigning the cat in the 0th index, and then 1 in the, sorry, dog in the first index. So this will give you the label of cat. So if it is 1, so it gives you 0, 1. This will give you the label of dog. So this is an easy way to create a array of label. So this is what we're going to use here. So here, if you're having 5 classes, class labels, then you can declare 5 here. Then you may have a cats and dogs, or bull or some other animals, like you can just label them 3, 4, 5. Here you can mention the index, and then the value will be the one will be placed in the particular index. So that's why we are using here NPI2, since we are using only 2 labels, cats and dogs, and it will fill the one according to the the label which we are getting from the iteration. So that's it. And now what we're gonna do, we are gonna count the number of cat images and the dog images here. So the label is equal to self.cats. Then we're gonna increase the cat count. One. Else if dogs, then we are increasing the dog count. We should get almost equal number of cat and dog images. And we're gonna do one more thing. We're gonna add one more thing to avoid the crashes. So I'm gonna add the try catch, since the images may get crashed while loading and converting or resizing, since we are having the size of the images in different dynamic sizes. I'm catching the exception and doing that thing here. So simply we are passing, excuse me. So we have almost done processing the data. Now we have to store the data once it is done. So before storing the data into a file, we are going to shuffle the data, training data that we have created. So for that, I'm going to use np.random.shuffle, and we're going to pass the train data which we have created, and then we are going to store this data into a NumPy array file. .npy, and pass the array value here. And at last we are going to print the count of dog and cat. If true, we are going to run this preprocessing. So once it is it's going to be done only once. Once the pre-processing done, we're not going to run this pre-processing anymore. So currently I'm going to run it only once. Since this is the first time, I'm going to keep this as true. If it is true, then we are going to run the pre-processing. Otherwise we are not. So I'm going to instantiate the class which we have created, cat with dogs, and our class name is cat and dogs. And we are going to call the make a train dataset function. So here we have almost done everything. So now it's time to run and check. So it's throwing some error. Module object is not callable. Okay, so the error is showing up that TQDM here, the 14th line number 14. The TQDM module is not accessible. I mean, object is not callable. So here what we have to do, we have to import the TQDM module class from TQDM. TQDM module. We are importing the TQDM module, sorry, class. So now it should work. Let me clear this. There you go, it started running. So now it's processing all the cat images. It's pretty quick. So you can see the number of cat images and dog images are almost same. So we don't have to worry about the balances of data sets. So it's been created, and so there you go, our data set is created, train_data.npy. So now we're going to load this data and see. Train set is equal to np.load train data. Come on, hello pickle. It's equal to true. So this will load the data into the memory, and then we're going to print the label. So let's just print the length of the data sets first. So it's showing the added value of this too. So it's loaded properly. Now we will print the value in it. So this will contain the first elements, image and label. So this is the image, array of image, and I mean this shows the data type as uint8 since we stored the image as grayscale. So this is the array of image, and this is the label of that image. And if you want to print only the label, you can print it. There you go, that's the label. So which means cat is 0, the 0th index is 1 means cat. If this one is 1 means it's a dog. So that's the way we just created the data set. And we can also visualize this data set by matplotlib. So for that, import matplotlib.pyplot as plot plt.imshow of train set 0 of 0. So this should show the first element image. There you go. So it seems like a dog here, I'm not sure, so we can check with another image. So this one clearly shows it's a dog. So this is what we're going to feed into the neural network. So now our data set is created and I mean like cleaned up, resized into, you know, same size, like 50 by 50, and which is also grayscaled. So we've almost built the clean data set now, so it's ready to feed into the neural network. So this is the basics of creating the pre-processed data set. Since we have used the beautiful data sets from Microsoft, we can also use our own collection of images as well. If you have a collection of other animals, you can just feed that images into this data set. You can add one more class into the labels, and you can make the training with the neural network which we're gonna create in the next tutorial, and we can do some classification on that. So that's all the basics about the pre-processing of data sets. So thank you so much.